Welcome to Real GMAT Problems, episode 29. Doing real GMAT problems is one of the best ways to make sure that test day is as easy as it can possibly be for you. So let's talk through a few examples together. The problems that we're going to go through are from the 11th edition of the official guide for GMAT review, and you're welcome to web search them if you would like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going to go through questions from that book, because that way, if you purchase this year's official guide, which is a good general recommendation, there shouldn't be any overlap between the questions that we're going to work through here together. The official guide contains retired problems that have appeared on past GMAT exams. So these are going to be really, really similar to what you're going to see on your official GMAT. I'm going to give you a chance to work through the solution on your own if you'd like, and then I'll discuss my thoughts on the problem and what I recommend that you take away from each one. I would recommend pausing after I read through each problem and at least trying to solve it. If you're on the go, you might have to visualize a solution, like if you're biking or running or at the gym or something like that. And so you might not be able to execute every single step if in your head in that case, but just do your best. It's a great mental workout. If you are in a situation where you can physically write down what you would on test day, that's definitely ideal. Let's go. I'm going to start us with a warm-up problem today, and then we'll jump into some stuff that's clearly a little bit more challenging for people. So we're going to start a little bit lower on the end of the difficulty spectrum. And if you're just starting out, this might be hard. If you've been studying for a while, hopefully this is going to be pretty smooth sailing. And then, of course, a lot of us are going to be between those two extremes. This is problem number 125. The problem says if P divided by Q, that fraction, if P divided by Q is less than 1, and P and Q are positive integers, which of the following must be greater than 1? I'll read that again. If P over Q is less than 1, and P and Q are positive integers, which of the following must be greater than 1? Option A is the square root of P divided by Q. So to be clear, it's P over Q, that fraction, and then the square root of that entire fraction. Option B is P divided by Q squared. Option C is P divided by 2 times Q. Option D is Q divided by P squared. And option E is Q divided by P. Again, I recommend pausing and at least attempting to visualize your own solution path here. This is a good warm-up problem because there are a few pitfalls, but there are also quite a few different approaches that can yield a good result. So it's a good little stretch, I guess, and kind of like potential mind expander in the sense that like your default approach might be great, or you might want to consider one of these alternate approaches that I'm going to discuss. It's also a good warm-up problem because I think if you're solid on your basics, you're very likely to get it right. If you did miss it, that's totally fine. It's better to be wrong in practice than during performance. And this is a good opportunity to sharpen your basic skills and get to the next level, which of course is the whole point of studying and why we're here right now. It's to improve, not necessarily to get everything right in practice. Although obviously it's great if you get everything right in practice. I just don't know how realistic that is. I certainly didn't. And most of the time it was the questions I got wrong that I learned the most of and and I ended up profiting from the most on test day. So let's jump in. Let's talk through an algebraic approach first, since there's a few valuable points to make on the algebra side. The first point is that all the same rules of equations apply to inequalities. P divided by Q is less than 1. That's called an inequality. If you're just starting out or you're not familiar with that terminology, we've got an entire Math Basics series linked in the description of this content to help you out with that. And just reskill or upskill if, it might have been a couple decades since you thought about the difference between an inequality and an equation. It happens. It's probably important to note that there is one major difference when operating on inequalities that we don't have to think about when we're operating on equations, which is that if you multiply or divide both sides of an inequality by a negative value, you'll want to invert the sign. So the greater than symbol becomes the less than symbol when you're multiplying and dividing by negatives. and the less than symbol would become the greater than symbol. So think about a simple example like 5 is less than 6. I think all of us would agree on that. If I multiply both sides of that by -1, I would get -5 is less than -6. That's what would happen if I didn't invert the inequality sign. And if you think about it, -5 is not less than -6. It's actually bigger. So that's a good example of why you want to invert that sign when you multiply or divide both sides by a negative. If I have 5 is less than 6 and I multiply both sides by -1, I should flip the inequality sign to get -5 is greater than -6. So most of you probably aware of that, especially if you've been studying for a while, but if not, super, super important. What's interesting though on this problem is we don't actually need to worry about that because we're dealing with only positive numbers. The problem tells us this directly. It says P and Q are positive integers. Obviously, 1 is a positive integer. And if you're not familiar with that whole integer terminology, that's also covered in the Math Basics series. So in an algebraic approach to this question, we are just going to use what I like to call the golden rule of algebra, which is whatever you do to one side of the equation, you do that exact same thing to the other side of the equation. And that applies equally well to inequalities. Whatever I do to one side of the inequality, I do that same thing to the other side. So let's multiply both sides of our inequality here by Q. That gets us P is less than Q. Then let's divide both sides of the equation by P, and that gets us 1 is less than Q divided by P. And that's our correct answer, which is option E as an echo. So obviously it's a great approach. Let's talk about how you can recognize that that's going to work well, because I don't know that that would necessarily be intuitive for most of us. So we'll talk through a couple clues. The first clue is that the problem presents you with something less than 1, but then it asks you for something that's greater than 1. So in situations like that, it's really, really likely that you'll be able to manipulate the expression to solve for what you want. So if you're given something less than 1, you're asked for something greater than 1, or there's like a lot of similarity between what you're given and what you're asked, highly likely you'll be able to use some algebraic manipulation to solve for what you want. So that clue by itself could tip you off to be like, oh, let me just see if I can multiply and divide here, and then bam, there's your answer. The second clue that you can use is glancing at the answer choices, which you might recognize are all recombinations of P and Q in a bunch of different ways. So if you're presented with an expression involving P and Q, and the answer options are all different variations of that expression, like we have here, that can be also a good signal that algebra is going to be a good approach to use. Let's pretend you recognize that it's a good situation for algebra and you execute well, highly likely to get this one correct, and probably fairly quickly at that. But again, if you didn't recognize that, that's no problem. Like I said, you're here to improve, and hopefully you'll be able to recognize that type of situation in the future as a result of engaging with this material right now. And that's the whole reason we want to do real GMAT problems together. Now, I mentioned that there are some other approaches that can work. Just going to briefly touch on those. One technique we've spoken about in past episodes quite a bit is plugging in numbers. And that approach generally works when you see variables in the answer options like we've got here. I'm not going to go through the full solution on that just for the sake of brevity, but quickly talking through it, we need to just pick numbers for P and pick a number for Q as well. And we just need to make sure that the value for P is less than the value of Q and that they're both positive integers. Basically, we just need to obey the constraints of the problem. And then that way, we're obeying the rule that P over Q is less than 1. If I pick a P that's 100 and Q is 2, 100 over 2 is not going to be less than 1. So I'm not allowed to do that. The problem tells me quite clearly P over Q has to be less than 1. So as long as I stick within those constraints, I can pick any numbers that fit them, and the technique should work. Now from there, all we have to do is plug our values into all 5 answers and see which one is greater than 1, because that's what the question's asking us for, which of the following is going to be greater than 1. Depending on the values we picked, we should get to option E fairly quickly. Again, not going to go through the whole song and dance there. You're welcome to try it out on your own if you're curious about it, but it's worth noting that we're not really supposed to be able to plug in numbers on GMAT questions. Like the questions aren't designed to do that. It's just a really helpful technique that just happens to work in those situations. So the reason I bring that up is sometimes you can get more than one answer that works. And if that happens, it's not that big of a deal. Just choose new numbers that fit the problem, repeat the process, and generally you're going to narrow it down to one option at that point. But if you stay away from plugging in numbers like 0 and 1, like basically if you never plug in 0 and 1 when you're using that plugging in numbers technique, you'll avoid that pitfall, I would say 99% of the time. Really, really useful technique. We've got a whole episode fleshing out that technique of plugging in numbers. If you're curious to learn more, we'll link that for you in the description of this content as well. It's very worth checking out if you're not familiar with it already. Finally, you can use some logical reasoning to get this question right. For example, if you know that P has to be less than Q in order for P over Q to be less than 1, then you also know that Q over P is going to be greater than 1. So let's just reason through that together. So think about an example like 5 over 6. If P is 5, Q is 6, 5 over 6 is less than 1. If I flip that, 6 over 5 has to be larger than 1. Or think about an example like 10 over 11. 10 over 11 has to be less than 1. 11 over 10 would have to be bigger than 1. Again, in order for the original fraction to be less than 1, the inverted fraction would have to be greater than 1. And I would say the majority of GMAT test takers are probably not automatically going to think of that and go to that kind of approach, but some folks do. And just want to mention that it is a totally viable approach if that resonates with you. Now, if that's not the natural place for you to go, but it is appealing and you're like, I would like to be able to think about problems like that, I just want you to be really cautious with that kind of reasoning until you've practiced enough to have a lot of success with it, because it can backfire quite easily. It can sometimes lead to mistakes. I think actually in the last couple episodes of this series, I talked through a few examples of how that kind of algebraic reasoning can be dangerous. And so it's definitely something you want to use with caution. When it works so well that it's easy to sell ourselves on it or like oversell ourselves on it. Like, oh, I want to do it that way all the time. And that that sounds great in theory, but in practice, as you might have noticed from doing some of the more challenging questions that we've done in this series together and like some of the ones we're going to do later, most of the time the slower way is the safer way. And for a lot of us, frankly, the better way. Now, it's not that we want to prioritize slowness or that we want to deprioritize speed. It's just we want to use fast approaches when we're not going to be fast and wrong. And that sounds just so painfully obvious. I know I've said it so many times if you've been a long time listener, but it really does bear repeating because speed is just really seductive. And it's easy to sell ourselves, it's easy to oversell ourselves on techniques that are just too dangerous. It'd be like winning the lottery as your retirement plan. You know, that's maybe a kind of an extreme example. And it's like, hey, if it works, probably works great. But we just want to be realistic about our odds there. So I did want to mention that and also give that caveat. Having said that, if you look for opportunities to use that kind of algebraic reasoning, even if it's not natural for you, and you practice a lot with it, and you start to figure out the kinds of situations where it works well for you and the kinds of situations where you should slow yourself down and use a more methodical step-by-step approach, then you're studying the right way for sure. But I just want to caution you against being like, oh, I'm just going to use that 100% of the time. Very, very few techniques work 100% of the time on the GMAT, everybody. And that's why I'm taking so much time here to talk to you about all of this, because I don't want you to go down the path that I went down, which was super painful and just like took 3 times longer than it needed to. And just was obviously things worked out. But I mean, holy smokes, it was just really tough. So if you're already really comfortable and well rehearsed with that reasoning approach, by all means, keep using it. If there are any notes to self that you want to make regarding this question, I'd recommend pausing and making those now. If you have any questions about anything we're discussing here today or really anything at all GMAT related, feel free to get in touch with us anytime. We're at the GMAT Strategy on current social channels, or you can email us at contact@thegmatstrategy.com. And we should be able to help you out. We've been through this tens, hundreds of thousands of times at this point, probably. And if you're having an issue, we've probably dealt with it and solved it before. And we're happy to share as much as we can over DM and email, just for the good of everybody, basically. So let's tackle some questions that seem a bit more challenging for folks just based on the numbers. Again, don't stress about being wrong on these. Just focus on improving, and eventually you will get where you want to go. This is problem number 123. The problem says the price of lunch for 15 people was $207, including a 15% gratuity for service. What was the average price per person excluding the gratuity? Let me read that again. The price of lunch for 15 people was $207, including a 15% gratuity for service. What was the average price per person, excluding the gratuity? Option A is 11.73. Option B is 12. Option C is 13.8. Option D is 14. And option E is 15.87. Again, I'd recommend pausing here and working on your own because I'm just going to jump right into my explanation. Great word problem to polish your percent and word translation skills. We've got 21% of us all going for the exact same incorrect answer. That's likely based on a percent calculation mistake. So we're going to dig into that. It's a very avoidable mistake, but also very common and apparently very tempting. So let's try to fix that kind of mix up for everyone. And you might be surprised to know that 30% of us are missing this question overall, and only 70% of us are getting it right, which I thought was really, really surprising, given the nature of the math and like how short the problem is. But if you've been listening for a while, I think you probably heard me say that a bunch of times. And these are some of the most important problems for us to talk through because all of you have a lot of experience learning stuff. And there's also a lot of really, really great products, free and paid out there to help you learn the stuff, like learn the material, like, "Oh, I got to relearn the quadratic formula here, or like, oh yeah, like totally forgot how to do the surface area of a cube. It's good to be reminded of all that. And it does come up, or exponent rules, things like that. But eventually, if you practice enough, you will have all of those things down. And I don't think most people struggle with that piece. Most people feel like they know how to learn, especially after doing a whole undergraduate degree. Some of you have graduate degrees already. So I think it's surprising that a lot of us end up missing this. And I think that's where a lot of the confusion comes for a lot of folks I talk with every year is like, I feel like I know all this material. Why am I missing questions? Now, there can be a lot of answers to that. But one of the answers is this more process oriented stuff. And part of the reason I started this whole project many years ago at this point is I just realized a lot of people just aren't talking about that. They're not teaching it. A lot of professionals in the space, I mean, bless their hearts, they're probably really good people. And most of the people I've met in the space on balance are really good, but they just don't even realize how much people are struggling with this because a lot of the people who work in the industry are so intelligent. They're so smart. They just never struggled with the exam themselves. So it's really hard for them to imagine what it's like to know all the content and still miss lots and lots of questions. And yet, then we come to data sets like the one we have on this one, where out of, I think it's like 5,000 repetitions on this, 30% of us are still missing it. And you're thinking about like future MBAs, this is a pretty competitive group here. These are people who know how to work hard. They're intelligent. This isn't like, this isn't like the riffraff here. So what does that suggest? I mean, I think if we just look at that situation overall, it just suggests that a conversation about this probably should be had. So hopefully we're filling that gap for all of you. Okay, so again, great one to miss in practice. Definitely not something we want to be missing on test day. So let's jump into the trap here. Let's jump right into the trap because the first important place where it looks like a lot of us are missing this is the gratuity part. So the good news is that it looks like the large majority of us realize that we do need to remove the gratuity. And in the problem, the way it's written in the book, the word excluding the gratuity is in all caps. So the test writers are trying to help us out with that. Thank you for that, everybody who writes these tests. But the problem seems to be the way people are taking the gratuity out is incorrect. So let's work on that together. Quite a few of us appear to be taking 85% of 207. Okay, so we're thinking like, oh, 207 is 100% of the price. There was a 15% gratuity. If I just remove 15% of 207, then that's going to get me back where I started. And that's not true. The correct approach is increasing an unknown amount by 15% and then setting that equal to 207. That's really, really important. So let's dig into that a little bit more. We've discussed that type of situation and that type of mistake a few times in this series. It's extremely common and also really, really understandable. A lot of you are going to be brand new here, potentially going to be brand new to the exam, potentially going to have just be doing this problem in a distracted environment, or you're tired. Like, that's fine. There's still value you can get out of studying when you're distracted and tired. But you just want to accept like the hit rate's going to suffer there a little bit. So even those of you who are veterans might benefit from this question though, because it's just really, really easy to slip back into old habits, especially if you've been having success recently. So you see a lot of posts online about people getting a really good score and then the next score is really bad. Sometimes that's luck of the draw, but most of the time, and I really hate to say this, but I would want you to say it to me if our roles were reversed right now. Most of the time, it's because you stopped doing the things that got you that good score in the first place. It happens to the best of us. It's a very natural part of the human condition. Things start going well. We start to relax, ease off the process a little bit. We're not as hard on ourselves as we were when we were coming up the mountain, as it were. And it's a good lesson on a lot of really good basic principles. So just if you notice yourself getting complacent, you want to start to build the skill set, and it's okay if you're starting small and just working up from there. And that's what I did. If you start to notice yourself getting complacent, you want to just start building up your discipline and your willpower. We've got a whole episode on how to be more disciplined, and we'll link that in the description of the content. I didn't have that noted before. So let me just make that note, and then let me get back to the place in my notes where we were together. Okay, so that'll be linked for you below. Let's talk about what's wrong with taking 85% of 207. Think about a simpler example. Let's say you're purchasing a $100 item and you need to pay a 10% sales tax. What's the total price, including tax? Hopefully you're thinking it's $110, which is right. But what if we're buying a $110 item that's on sale for 10% off? Well, 10% of 110 is 11. So if we discount by $11, we get a final price of $99. Notice that a 10% discount on a $110 item is not $100. What's the point there? The point is that increasing a number by 10% is not the same as decreasing a larger number by 10%. Those are not the same things. So if that happened to you on this problem, or you've noticed that happen in the past, you want to make like a bunch of flashcards on this. You want to set this problem aside and redo it every single day until you can't forget it. It's like you really want to recondition yourself to think about percents differently if you are naturally thinking about them the incorrect way, which again is extremely common. 30% of us missing this question. It's hate to keep saying it. Sorry if I sound like a broken record, but it's just such a surprise. So the reason that 10%, the reason that that percentage difference is there, the reason that increasing a number by 10% is not the same as decreasing a larger number by 10% is because the increased number is bigger. I know that might just sound like comically obvious, but it's really, really worth discussing and hammering home because it just seems really intuitive to do it the wrong way. So the same percentage of a larger number is going to get you a larger result. That can be a little confusing because it is the same percentage. So some people feel like increasing 100 by 10% should be the same as decreasing the result by 10%, but that's the whole point. It's not the same. And that's really important for problems like this one that we're working on right now, because if I set an item's final price as $110, including a 10% sales tax, we cannot just take 10% of 110 and get the right original price that way. That's not going to work. We have to increase an unknown amount by 10% and then set that equal to 110. And that's the key to problems like this. So that equation would be something like 110 over 100 times P for whatever the price is equals 110. And then we can use algebra to solve for P. And there's a Math Basics episode linked below on equations and algebra if you want some help reskilling there. In fact, we'll also link a Math Basics episodes on percents if that would be helpful. That type of thinking is just critical. I mean, it's inescapably important because 207 is the price after the gratuity has been added. And if you simply decrease that by 15%, you're going to get an answer that's too small. And that's why we've got so many of us, 21% of us going for option A, which unfortunately is not right. And the really painful thing about that is there's some pretty intense math and computation involved in getting to option A. And so a lot of people are executing after that blunder like perfectly, and that's just super painful. So that's why we're trying to get this turned around. All right, naturally that brings us to how do we set this one up the right way? So we want to increase an unknown amount by 15% and then set that equal to 207. So our equation is going to look something like 115 over 100 times p equals 207. And then we can solve from there and everything's going to work out great as long as we don't make a mistake. But that first step is absolutely pivotal for almost 1/3 of us, which is, again, I know I've said this a million times, but like imagine 100 future MBAs, like the brightest folks in your generation standing in a room and 30 of them go down the wrong path on this question. That's way too much. So there are some stumbling blocks with the computation because it's not the easiest. And there are some other incorrect answers that apparently do get picked a good amount. But that first mistake is, yeah, I mean, that's just huge. So if you find yourself struggling with that kind of setup, then a good tip for that is the percent change formula can really help. And if you're not familiar with that formula, it's just new value minus old value, that difference divided by the old value, and then that whole fraction times 100. That'll equal percent change. I'm not going to go in depth on that right now because I've detailed it just to an absurd degree in past episodes, and I feel like I already am so repetitive on these pods, but repetition is the father of learning and the mother of skill, and so we do need it. But I'm just trying to do the right amount of repetition and not overdo it. But quickly, the way that the percent change formula could work here is again new minus old over old times 100. So it would be 207, which is the new value, minus p, the old value divided by p times 100, and then that equals 15. That's the percent increase that we're looking for. And if we execute the math there, we're going to get the right answer. So that will get you the same result without you having to struggle with the setup. If you tend to struggle with setting up percent increase or decrease questions, there's plenty more in the previous episodes in this series, so definitely check those out if you want a little bit more practice with the percent change technique. For now, let's assume that we could all get to 115 over 100 times p equals 207. Let's just say that we can get there. From there, we want to solve for p, which is the original price before the gratuity, and then that's going to allow us to answer the question. So I'm just going to run through the math here. Like I always say, you don't need to mimic the exact steps that I'm using here. It's just an example of how the computation could be done correctly. But pretty much any way that you want to compute things works as long as the setup's right. And that's why I've been spending so much time talking about the setup here. So let's divide both sides of our equation by 115 over 100. That's the same as multiplying by 100 over 115. From there, we get p equals 207 over 1. I think I've said in the past, I like to write my whole numbers as fractions over 1 when I'm doing fraction multiplication. I find visually makes me a lot less error prone. Again, not essential, but helpful. 207 over 1 times 100 over 115. From there, we can start canceling. 207 is probably a pretty unfamiliar number for most of us. So let's start by reducing 100 over 115 first. You might be able to tell that both of those numbers are divisible by 5. Quick tip, all integers that end in 0 or 5 are divisible by 5. Check out the math basics lesson on divisibility below if you're not sure what I mean by integer or if it's been a minute. And don't fear doing some long division if you need to figure out what happens when you divide both of them by 5. There's also a math basics episode on long division linked below if you need that. If you execute properly there, you would get 20 over 23. 100 over 115 reduces down to 20 over 23. Now at that point, most of us are thinking that maybe this isn't going to go so well because I've got 207 over 1 times 20 over 23, and that's a little bit gnarly, but that's okay. A good tip there is because there's no calculator on the GMAT quant section, it's safe to assume that numbers will often work out as integers, meaning like they'll divide or multiply evenly. Now, you can't say that 100% of the time. That goes back to what I was talking about at the top of the episodes. Few things work 100% of the time, but there are a lot of bets that you can make that are going to be like 80, 90% bets, and this is one of them. So it's a pretty safe bet to at least try doing long division of 207 by 23. Like it's highly likely that that's going to work out. And that's a good move because if you do that, you get 9. 9 times 23 is 207. 207 divided by 23 is 9. Basically, it works out cleanly there, even though it's a little scary sometimes when you look at the numbers. So we'll circle back in a moment to a technique you can use if you're struggling with that kind of thing, because it's not always easy. But for now, let's say we just arrive there and our equation would then be 9 over 1 times 20 over 1. So we get that fraction canceling right. So I'm just going to tie off the solution, and then we'll double back on the extra technique. So if we do the math correctly there, we get the original price is $180 before the gratuity, which is correct. And then we want to know the average cost per person for a 15-person group. So we just need to divide 180 by 15. That gets us 12, and that is our correct answer, which is option B, as in beta. Okay, so that's what a correct solution path could look like. Again, reach out anytime if you have questions. Let's talk about what you can do if you struggle to simplify the fractions, 207 over 1 times 100 over 115. A great move in those kinds of situations where you're unsure of what's divisible by what, or you're not sure if you can cancel, is to prime factor as many numbers as possible. Prime factoring is really, really helpful. We've discussed prime factoring before, but as a brief refresher, when you are prime factoring, you just keep dividing by prime numbers until you can't divide by prime numbers anymore. And if you need help with primes and understanding what those are, we got a Math Basics episode linked for you below. So let's start with prime factoring 100. Because that ends in 0, we know it's even, which is another way of saying we know it's divisible by 2. So if we divide that by 2, we would get 50. A lot of people like to make little factor trees when they're prime factoring. So they have 100 on the top, then they have 2 little like branches going down from 100, one with 2 at the end, one with 50 at the end. And then 50 also ends in 0, so we can branch that one as well, divide by 2 again to get 25, and then 25 we can branch again to get 5 times 5. And you just stop each branch at each prime number, and then that shows you the end of each branch is what's called the complete prime factorization of the number. If you multiplied all those primes together, you would get back to the original number. It's kind of like the DNA of an integer. Every integer has a unique prime factorization. Side note, but kind of interesting. So if we do that tree chart and we get our prime factorization and we do that for all the numbers, it makes it a little bit easier to see what's going to cancel where. So like you'll have some 2's in the top and bottom, you'll have some 5's in the top and bottom. If you prime factor 115, you'll get 23. If you prime factor 207, you'll get the 23. Like it's just like a nice bridge to figuring out what's divisible by what. It's really, really helpful on divisibility questions in general. I wouldn't call this question a divisibility question. It just happens to have some division involved in it. But prime factoring is really, really helpful in those kinds of situations. So I wasn't going to go deep on that, but figured I'd mention it because I have talked with a lot of people who really struggle with that kind of stuff, and I struggled with it a lot actually, because my divisibility instruction as a kid was not the greatest. And I had to reskill with that when studying for the GMAT myself back in the day, and the prime factor thing really, really, really helped out. Okay, so if we execute all that, then we get to our answer, and then we are good to go. So you might not need the prime factoring thing, but again, if you struggled, I think it's a good tip. So as usual, I recommend pausing here and just making any notes to self that you want to remember from this question, and then we'll finish off with one more. All right, feel free to pause. I'm just going to jump forward. This is problem number 124. It says, according to a car dealer's sales report, 1/3 of the cars sold during a certain period were sedans, and 1/5 of the other cars sold were station wagons. If N, meaning the letter N used as a variable, if N station wagons were sold during that period, how many sedans in terms of N were sold? I'll read that again. According to a car dealer's sales report, 1/3 of the cars sold during a certain period were sedans, and 1/5 of the other cars sold were station wagons. If N station wagons were sold during that period, how many sedans in terms of N were sold? Option A says 2 times N divided by 15. Option B says 3 times N divided by 5. Option C says 5 times n divided by 3. Option D, 5 times n divided by 2. Option E, 15 times n divided by 2. All right, feel free to pause and work more on this one. Really interesting problem, actually, with a lot of potential strategies. What I think is going to be the most beneficial to focus on here, because we've talked about quite a bit in this lesson and in past versions of this series, is let's just focus on the phrase in terms of and make sure that we really clarify that for everybody, because we've got 30% of us missing this question as well. Again, much higher than expected. Part of the reason I chose it for this lesson, it seems like a decent number of those misses center around a genuine misunderstanding of the whole in terms of phrase. And again, it's just one of those things that comes up a lot when I'm talking to people in the community about what's holding them back or about struggles they're having with questions. And it's just one of those little things that seems to make big problems. So let's fix that. First of all, the phrase in terms of means use a specific element or style to express something else. That's like literally what it means. It means use a specific element or style to express something else. For example, if I ask you to explain geometry to me in terms that a 5-year-old would understand, then what I'm asking you is to use only 5-year-old language to explain geometry. Explain or represent X in terms of Y means use only Y to explain X. And we can replace whatever we want with X and Y. Another example, if I ask you to describe your job in terms that someone outside your industry would understand, then I'm asking you to explain your work without using industry jargon, no acronyms, all that stuff. I'm asking you to describe it using everyday language that someone who does not work in your industry would be able to comprehend. So when a GMAT question asks you to express the value of something in terms of n, it's asking you to use the variable n only. Only use n to describe the thing. And another way of saying that is you'll want to solve for whatever's being asked with only n on the other side of the equal sign. And that's what we're going to do in our solution in a minute. Okay, so that's what in terms of means. You can see that reflected in the answer options. You'll notice that n is the only variable that appears in the answers, even though there are multiple variables in the question. And that's going to be the case with all in terms of questions. Whatever comes after in terms of is going to be the only stuff in the answer options, or the only variables, I should say. Obviously, there's other numbers in there, but I think you understand what I'm saying. So the reason for that is you're being asked to solve using only those terms. That's what in terms of means. So definitely reach out if you're unsure how to handle that or if you have additional questions, but hopefully that at least helps with understanding that phrase. I've come across it a lot. Again, it's a big pain point for a lot of people, very understandable, especially if you didn't have strong math instruction as a kid or up until this point in your life, but we're getting all that resolved today. Like we've discussed so many times in this series, a good approach to a problem like this is usually going to involve just writing what's given and asked really clearly and carefully. That's true for virtually all GMAT quant questions, but particularly word problems and word translations questions. If you've been listening for a while, hopefully I've already demonstrated the value of that. So let's say that we do that. The question asks us to solve for sedans, but in terms of n, meaning using only the variable n on the other side of the equation when we solve for sedans. So we're solving for sedans, but we have to do it only in terms of n. And then the question tells us that 1/3 of the total cars are sedans. Okay, so let's pretend we're writing all this. It also tells us 1/5 of the other cars sold are station wagons, and that's really important. 1/5 of the other cars is different than just 1/5 of the cars. And now that we have that basic lay of the land, we can start to formulate our solution. I think a good solution to a problem like this is probably going to start with a placeholder for the total number of cars sold, since all the quantities we care about in the problem are fractions of that total. There are a few different ways that we can approach that total, including making up a number and using a variable like t to represent the total. So both approaches have a lot of merit and they're worth exploring, but just for the sake of simplicity and to really drive the point home about the whole in terms of thing, I'm going to use a variable for the total and I'm going to solve with algebra. But the whole like create a number for the total thing, super, super viable and worth exploring if you want. So I'm just going to make t equal the total and I'm going to write that down. Always write what your variables represent. I know I've said that a bunch in the past. I'll probably say it again before this lesson's over. It's just super important small stuff like I was talking about earlier. I can start by setting up an expression for sedans, which would be 1/3 times t equals d, or some other variable to represent sedans. I'll use d equals sedans, t equals total cars. Once we have that expression for sedans, let's see if we can create an expression for the other given information in the problem. We're also told, again, 1/5 of the other cars are station wagons. And if you miss that other piece, by the way, if you just do 1/5 of the total is station wagons, then you're going to get the wrong answer really, really fast. That's not good. That's not good. A large percentage of us, about 20% of us, are doing that. So please read carefully, and I'll have a good tip for you for preventing that kind of thing in a moment, even if the reading piece is tough. So the correct expression would be 1/5 times 2/3 times t. So remember, 1/3 of the cars are sedans, 1/5 of the other cars. So the other cars is 2/3 of the total, and then 1/5 of that 2/3, that's station wagons. Okay, so really, really important point to make there, easy to miss. And that's how we get our correct expression there. So I'm going to use W to represent station wagons. So 1/5 of 2/3 of T equals W. All right. We are told at the end that N, the variable N, represents the number of station wagons sold. So instead of W, I'm just going to swap out N, and we'll replace that. So the question is asking us to solve for the number of sedans. I chose the variable D for that. And you might notice there's a wide variety of ways that I can solve for D. That would include T, that would include N, or some combination of those variables. And again, we don't want that. That's why the in terms of N phrase is so important. And once you do understand that, it can actually help you be a much better strategist on this question, because we've got three variables here, D, T, and N. We want to solve for D. That's what the question's asking for, but we only want N on the other side of the equation when we do that. So that what that means is we want to make T disappear. And if we can get an equation with D and N, but without T, we're going to be happy campers. It's a key inflection point in the problem. Without that, you can do a bunch of correct math and still not get the right answer. That's a big bummer. Let's keep that from happening. So I'm going to avoid a broad overview of substitution in general, because that's why we made the Math Basics episode for you, and it's down at the description of this content if you want it. But to get the right answer, we can use substitution to make T disappear. That's the beauty of substitution, is it can eliminate certain variables. So let's do that. Let's do that with our equation with N, because we want an equation with just D and N. If we replace the T in 1/3 T equals D with something that has N instead, we will have accomplished our objective here. So with our 1/5 times 2/3 times T equals N equation, let's do the fraction math. 1/5 times 2/3, that's 2/15. So we would have 2/15 times T equals N. Let's isolate T, and then we'll substitute in for T in the other expression. That'll make T disappear. So we're going to multiply both sides by 15/2 to get T equals 15/2 times N. And then we're going to substitute that in for T in the other expression. So instead of 1/3 T equals D, I'm going to have 1/3 times, in parentheses, 15/2 times N equals D. And that's awesome, because now we've got our equation with just N and D in it. And that's what we wanted. So we'll solve for D here. Fortunately, that's already isolated. So we just need to do the fraction math. 1/3 times 15/2 gets us 5/2. Okay, gets us 5/2. So we would have 5/2 N, which is the same as option D, as in delta. That's our correct answer, 5 times N divided by 2. Okay, hopefully you can see why clarifying the in terms of N piece is super, super helpful there, and how if you're confused about that piece, the problem gets much, much more difficult. Real quick, let's double back on the wrong answer and what happens if you're doing 1/5 T equals station wagons. Again, super understandable mistake. It looks like people are just reading the problem as 1/3 of the cars are sedans and 1/5 of the cars are station wagons. If you set up the problem like that, it quickly leads to C as in Charlie, which is the wrong answer. So if that's what happened for you here, a good little tip on that is always double check whatever you transcribe from a word problem. Really from any problem, actually. Let's just say always double check what you transcribe from the problem. So the problem's going to be on the computer screen on test day, but all your scratch work is going to happen on the scrap paper or whiteboard, whatever you're using. And so transcription is really, really key because if you copy down the wrong thing, perhaps obviously you do a bunch of correct math and still get the question wrong. So if you wrote down X, Y, and Z, just do a quick reread of the problem text and make sure that what you wrote down is accurate. That's all I mean by double check your transcriptions. It's a simple, simple tip, extremely powerful. I use it all the time. Pretty much anytime I translate something on a GMAT problem, I look back up the computer screen, look back at what I wrote. Did I transcribe everything quickly? Usually saves me 1 to 2 questions per exam. It's really, really valuable. So if you found yourself falling into that, that's a good way to prevent that from happening. It's a really innocent mistake. So it's tempting to sweep it under the rug, like when it happens and be like, oh, it's not a big deal. I won't do that again. But I'm just going to tell you, like person to person, it's a really big deal. It's a huge, huge deal for the vast majority of people. Like I was saying at the top of the call, sorry, top of the episode, a lot of you are going to know the material really, really well very soon. And then those process oriented things can just, they can just undercut you. And it's so frustrating. That's what happened to me for sure. It took me way too long to figure it out. So hopefully doing you a solid here, everybody. If you think about it, if you're not getting credit for what you know on the exam, it's technically impossible for you to get a score that accurately reflects your skills and the effort that you've invested and your candidacy for these programs. So again, might be annoying to deal with these kinds of things. I find it super annoying to double check my transcriptions 100% of the time, but it's just so valuable that it's worth it. It's worth transcending that annoyance and just getting out of the 30% of us who are missing this question. Definitely no need for that. One final time, I'll just recommend pausing and make any note to self that you want to remember. You can text yourself, email yourself, add something to a note, make a flashcard, and feel free to pause while you do. And we will be back very soon with more strategies, more questions to go through, more potential pitfalls to hopefully get you ahead of and keep you from falling into on test day. In the meantime, if you would like more help and more strategies and more tips for increasing your score on the GMAT, then please head to our website, thegmatstrategy.com, which is linked in the description of this content. And check out our free video on how you can reach your dream GMAT score in half the normal time. I know that sounds crazy, like a crazy bold claim, but even the simple advice that I talk through in the video and some of the case studies that I show you should really help you not fall into the major pitfalls that I fell into. Some of the stuff that we talked about today. I mean, basically, like we could almost say this entire podcast is just a culmination of many of the mistakes that I made in the process. Obviously, it's a lot of what I've learned from helping out so many people at this point in the process. But that video is really a distillation of the main key things that cost me the most time and caused the most frustration and like self-doubt and like lack of belief in myself that I was going to be able to make it happen, all that stuff. So highly recommend checking that out. In the meantime, though, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies, no matter how difficult it gets. It's totally worth it, I promise. You have so much to offer the business community and the world at large. Business leadership in general is one of the most powerful influences on everybody's human life worldwide. And so this really matters what you're up to here. And myself and everyone at TGS behind the scenes really wants to support you as much as we can. So please stay consistent and stay positive. Talk to you all soon.